Okay, welcome everybody. I'm Sébastien Deleuze, and today I'm going to talk to you about how to build functional web application with Spring and Kotlin. So we have quite a lot of topic to see today, so we are going to split this talk in 4 parts. We are going to talk about 4 steps for switching, beginning to switch from Java to Kotlin, then to leverage the Kotlin support there is in Spring Framework 5, migrate to WebFlux, and then use the functional API of WebFlux. So the first step is switching from Java to Kotlin. Today, I guess, you are using the most common stack, which is Spring Boot 1, Spring MVC with Java 8. And we are going to see what that means to change the language only and switch to Kotlin 1.1. So Kotlin is a language created by JetBrains. It's an elegant and pragmatic language. It allows to write concise code. It's simple and easy to learn, and it embraces both functional and object-oriented programming. And it has a very good Java interoperability. How does it compare with Java, for example? I think it keeps the good parts of Java and tosses the bad ones. Kotlin is as statically typed as Java. In my opinion, it's more suitable for functional programming. Kotlin stole some good ideas to Groovy, but is statically typed by design, while Groovy is a dynamic language that provides optional static typing. And in practice, that makes a big difference. Kotlin produces also a cleaner and smaller bytecode. Compared to Scala, I think Kotlin is a little bit less powerful, but much more simpler and more pragmatic while still being elegant. And Kotlin and Swift are very close and both great languages. So Kotlin 1.0 has been released last year, and Kotlin 1.1 this year, so adoption started from very low, obviously, but increasing very fast. And I don't know if you have heard about that, but 2 days ago, Google announced official support for Kotlin on Android, and that will really, that's a huge news for the language, and that will increase the adoption even faster, even on server side. So concretely, why should you switch to Kotlin? Because that's a new language. You are all used to Java 8. Java 8 brings huge improvement compared to Java 7. So what advantages there are? The first one is it has a familiar syntax. I mean, there is some new syntax to learn when you know Java. But I really think a key advantage of Kotlin is that it allows you to leverage your Java knowledge and improve it. So it has familiar syntax. You have class, like in Java. Class are public by default, so you don't have to add the keyword. Val means unmodifiable and var modifiable. Function are identified by the fun keyword. You can see that the type is suffixed, so you put the type after the variable. And you have a short syntax when your function is only one line. You have this short syntax with equals, if, and if is an expression in Kotlin, so you can put it directly as a return value. Everything is statically typed. I will talk again about that. A second good feature of Kotlin is type inference. So I insist Kotlin is as statically typed as Java, but provide a short syntax like Groovy, for example, because it has a clever type inference. In this example, A equals ABC, and the type of A is inferred to string by Kotlin. For B, B is inferred to ints, and you can also specify explicitly the types. So you will see with more complex examples, the type inference of Kotlin is quite interesting. You have string interpolation, so that allows you to write. Oh, I think I have some issues with my laptop, but I will continue. So you have string interpolation. You have string interpolation that allow you to write dynamic strings. Just let me. Okay. That's my new Linux laptop, so. Okay, let's continue. So you have string interpolation that allow you to write dynamic strings, and you can expand the variables with this nice syntax. You have smartcasts. So smartcasts allow you to, in this if statement, you can see that obj is it's a global object, and in the body of this if statement, Kotlin compiler is able to know that obj is a string, and you don't have to explicitly cast it to a string. It is automatically a string, and two uppercase method is available. You have intuitive equals. So the double equals means structural equality, and the triple equals mean referential equality. You have default parameters and optional parameters. That means that I have a single build function with a mandatory title, a string parameter, and you can also specify parameters with default values. So if you just call build foo, width and height will take their default values, and you can also specify just foo and the first parameter, and the last one will take its default values. So that avoid you to create multiple variants of multiple overloaded variants of your method. You have also name parameters that allow you, for example, to set the title and the height without specifying the width one. You have a when expression, which is a more powerful switch statement that allow you to take in account all the various possibilities. You have properties, so properties automatically generate getters and setters and allow you to customize them if you want. You have extension functions. That's a pretty interesting one. Extension in Kotlin allow you to add a new function in an existing type. So in this example, I'm adding a format function to the string, the regular string type from Java, and that allow me to call string.format even if format was not expected in the original string type. Extensions are statically resolved. You have to import them like static imports, but the IDE does a pretty good job to propose you by default that, so that's interesting. And Kotlin standard library is provided with built-in JDK extensions that provide you additional functions for string, for collections, and things like that. Another very important feature is null safety. So in Java, you don't really deal, the type system don't take in account null safety. So you don't know if a value can be null or not. Usually we try to specify that in our API, in the Java doc, when we don't forget to do that. But the tooling can't use that, and the compiler is not aware of that. That's why we have this null pointer exception at runtime. So Kotlin deals natively with null safety in its type system and allow you to specify if a type is nullable or not. So if by default the type are not nullable, so if you write var a of type string, it's non-nullable. So if somewhere in your code you try to affect a null value, this will raise an error at compile time. And if you want to say that's a nullable type, you add a small question mark at the end of the type. And here the value could be nullable, and you have various operators for safe calls, and you can provide, for example, a value if the variable is null. You have also better lambdas. So in Kotlin, you have high order functions that allow to define a function only with its signature. So here we have a function that takes two int parameters and return another int, and you just have to call it. You have some shortcuts in terms of syntax. So if you can remove the parentheses for the last lambda parameters, so these three variant of filter are equivalent. Also, if you have just a single lambda parameters, you can omit it, and it will use the it default parameter, allowing shorter syntax and allowing you to write concise functional code. There is much more functionalities. We are going to see other functionalities later. Data classes, type aliases, coroutines, refine type parameters, underscore for unused parameters. We will see that later. So for you, the easiest way to start a new Spring Kotlin project is to go to start.spring.io. You enable the advanced mode and you select the Kotlin language, or you go to this customized URL, and that will by default display and select Kotlin code, and then you just choose Maven, Gradle, and that generates a new Kotlin Spring project. Let's have a look to a Spring MVC controller written in Kotlin. So you can see that it has the same, it looks like a Java 1, but with a few differences. First, you can see that it is shorter, the code is concise. You don't have to specify public at class and member function level because that's the default. You can use the short syntax for one-liners, which allow you to directly write the function body with equals repo.find1id, for example. And I insist, everything is statically typed, like in Java. The type inference of Kotlin, for example, for the save method, the save method of the controller will have the same return value type than the user repository.save. That's automatically understood by the compiler, and your compiler is as statically typed as Java, even if the syntax is as short as in Groovy. You don't have to specify the @autowired since Spring 4.3, so it will automatically inject the user repository since there is a single controller, a single constructor. When we started to build Spring project with Kotlin, there was a trap. We had to put the open keyword at class and member function level for all bins employing CGLib proxies, because Kotlin has classes and methods final by default, and you have to put the open keyword that's the opposite than Java. And the point is that with CGLib proxies, we need to extend, for technical reasons, the class at the runtimes. That's why you had to put that. And we discussed and worked with JetBrains to create the Kotlin Spring plugin. So they created that, and basically with this Gradle and Maven plugin, annotated class or functions with Spring annotation are automatically opened, and you don't really care. So if you just use the Kotlin Spring plugin, you won't have to do anything that will be like in Java. You don't have to care about this open keyword. Another pragmatic plugin, I would say, is kotlin-noarg that allows you to use. So this is a code from one of my Kotlin applications. That's for my domain model. And you can see that this is a domain class with a few mandatory properties and some optional ones. And there is no default constructor. So by default, GPA and Spring Data are not happy. So these plugins allow you to use this kind of domain classes without any issue. In addition to Google, Gradle announced a few months ago that they are going to officially support Kotlin. That means that in addition to the regular Gradle build files written in Groovy, you will be able, and you are able nowadays, to write them in Kotlin. So the syntax is almost quite close to the Groovy one. The big advantage is that everything is statically typed, so you have full compile time check, you have full autocomplete, and that's why Gradle is moving to Kotlin. Maybe at some point that will be the default. For them, that's really very important to be able to move to a statically typed API while keeping the same short syntax. And if you build Kotlin project, that allows you to have your build file written also in Kotlin, so you have one less technology to learn. Let's now see about what that means upgrading to Spring 5, because what I have described is just using Kotlin with Spring Boot 1 without any specific support except the Maven and Gradle plugin. So now we are going to upgrade to Spring Boot 2, and Spring Boot 2 means also Spring Framework 5. So Spring love Kotlin, and really with Spring 5, we are officially supporting it. So it will be supported at the same level than Java, and that's not some small addition. We really officially support Kotlin to build Spring projects. I announced a few features and this support at the beginning of the year, and I was very surprised because the feedback from the community was huge. A lot of retweets, a lot of comments, a lot of good feedbacks, and a lot of contributions, with a few extensions contributed by the community. So that's interesting to see such feedback. So let's talk about the feature that we are going to support in Spring Boot 2 and Spring Framework 5, and you can already try that. We leverage Kotlin nullable information to automatically determine the request param and the auto-wired required attribute. What that means that if you annotate with request param a nullable type, the request parameter will be optional, while if you annotate the same type but the non-nullable type, it will be mandatory. That's the same for auto-wired. If you annotate with auto-wired a nullable type, the bin will be optional. If there is no such bin, that's not a blocking issue. If you annotate a non-nullable type, that means required equal true, and we will raise an error if such use case occur. We provide a wide range of extensions via the Kotlin extensions mechanism I talked about previously. So Spring Framework 5 comes with application context, Spring MVC, Spring WebFlux, REST template, and JDBC extensions. We are going to see an example just after. Spring Boot 2 will also provide Kotlin extensions. Spring Data K, upcoming release, will provide that. And Reactor 3.1 provides Kotlin support with Reactor Kotlin extensions. So let me be clear, by default, you don't have a Kotlin-specific API. We just use, with the great Kotlin Java interop, the Java API of Spring. But this extension provides some additional methods. A concrete example is leveraging reified type parameters. In various places in Spring, you have to specify explicitly the type that you want to serialize, deserialize. For example, that's true for REST template, for WebFlux, for Spring Data, Mongo template, for example. So in Java, for example, you have to write Mongo template.findAll user.class, even if the returning value is explicitly declared as list of user. So one sample extension that we have added is this kind of reified alternative. So I'm adding a new findAll method to Mongo operation. It does not take any class parameter, and it will leverage. You see that I'm finding the type thanks to the generic parameter of list with Kotlin. So that's a way to avoid the type erasure issue, and that allows us to write a simple Mongo template.findAll, and it avoids us to not repeat the user type information. So when you write code with REST template, WebFlux, or Spring Data, that's allows much shorter code. Another topic we are working on, so this one is experimental. I'm not sure yet we will be able to make it for Spring 5.0. I will try, but see some work. We try to leverage GSR 305 annotations to bring null safety to the whole Spring API. Basically, by default, Kotlin considers that the Java API of Spring for parameters and return values, the null safety is unknown. And Kotlin compiler could leverage annotation that we could put in Spring Java API to know the null safety of return values or parameters. That means that we try to add annotations at package level to say the default for all parameters and return values is not nullable. And if we add at nullable annotations, that will mean that this particular return value or parameters is nullable. And that will be very, very useful for Kotlin project, because that will make all the Spring API null safe. But that will be also useful for Java developers, because IntelliJ IDE and Eclipse are able to leverage this API to do static code analysis and to generate a warning if you are doing null unsafe operations. So that's also something that matters for Java developers. I hope we will be able to make that for Spring 5.0. Another thing that you can do is write specification-like tests with Kotlin and JUnit 5. There are some Kotlin-specific framework for testing, like Spec, for example. But by just using the Kotlin language, you are able to write expressive function names between backtick, like that. So that means your test name much more explicit. And JUnit 5 allow to add nested classes that allow you to basically write this kind of test. And when you run them, you have a nice specification like result, and that read very well and that produce very nice test result. A limitation currently with JUnit is that when you want to run some code before or after all your tests, it has to be a static method. And Kotlin directly don't support static method, but there is companion object which is similar. But that leads to non-idiomatic code. So the good news is that JUnit 5 next milestone will remove the need to have static methods on that, and it will just support before all and after all annotations on regular non-static member functions. Like you have seen, I like to promote using Kotlin everywhere. So why not using it to write type-safe templates? I mean Spring MVC view templating. So you can, there is a GSR 223 support in Spring MVC, and we have added support in Spring WebFlux as well. That allow you to write templates with regular Kotlin code. So this example is a multi-line Kotlin string, a regular one, and I write Kotlin code thanks to string interpolation. And the very nice feature is that these templates that you are using to create web pages rendered on server side are type safe, so they support refactoring, they support check at compilation, so that makes your templating much safer. Now, let's see how we can migrate to WebFlux. So in this third step, I will change Spring MVC to Spring WebFlux to turn this application to a reactive web application. So you have seen quite a lot of talk maybe about reactive, so I will be very quick. What problems are we trying to solve by going reactive? I think the first one is scalability. If you have many slow connections, each connection means one thread, and many threads that do nothing consume some memory, consume some CPU. So reactive web framework like WebFlux can solve that. That's also very well suitable for infinite stream like SSC, server-sent events, or WebSocket. And if you have slow remote services, for example, when you are building microservices, or just if you are just calling a remote slow web services, that will also block some threads, so reactive runtime solve issues there. So going reactive is more for scalability and stability than for speed. So in Spring Framework 5, in addition to the regular Spring MVC stack that we continue to support, and we don't say that's deprecated, it's supported, and that's perfectly fine to build on top of that. We are adding Spring WebFlux based on Reactive Streams. So Reactive Streams is a way, is a specification to for data transfer between a publisher and a subscriber. So the subscriber subscribes to the publisher, it requests data, and when the data are requested, so request 1, 2, 3 elements, the publisher sends the data to the subscriber, but never more than requested. That's the back pressure. And then the transfer, the exchange, eventually complete with a complete successfully or error event. You have a few Reactive Streams-based API. You have Eric Java 2, Reactor Core 3, Aka Streams. In the coming example, I will use Reactor as an example, but you can use the one you prefer. Flux is a Reactive Streams publisher for 0 to n elements, that it provides a rich set of operators to transform your incoming data. Mono, it's the same, but for a single element, so it provides a subset of operators that are suitable for 0 or n element or 1 element. And this Flux and Mono API allow you to write the same kind of web application that you are building today, but implemented in a non-blocking way with a non-blocking runtime. And it also allows you to create new kind of systems where, for example, you are going to consume streaming API like Twitter one with the WebFlux, which is suitable for streaming, WebFlux client. You merge that with some other data that you get from remote web services, and you publish that as a dynamic stream through server-sent events or WebSocket. Really, WebSocket is really, WebFlux, excuse me, is really designed for that kind of use case. The link with the topic of this talk is that reactive APIs are functional APIs. You are not going to write imperative code with one line per operation. We are going to build a reactive pipeline when you describe the transformation applied to the incoming data. So if we take this example, we have a fetch weather method that returns mono of weather, so that's a little bit like a future value of weather. And the first step is to call fetch weather. Then we define that if there is no answer before 2 seconds, we emit an error. When there is an error, we print that in the logs. And we are going to call a backup service. So we can imagine that the backup service is a local one with outdated data, but we are sure to be able to reach it. And basically, if there is an error, so if there is no answer before 2 seconds on the main service, it will use fallback on the backup one. Then we transform the weather object into a user-readable message, thanks to the map operator. And just before, we had just defined the steps that will be executed when the data will be received. So then we subscribe, we trigger the processing of the chain, and everything will be executed. So a side effect of going reactive is that you are going to move from imperative code, like you write today, to functional programming. And that's here where Kotlin is a good fit, because Kotlin is a more suitable language for functional programming. I mean, it's totally possible to do that with Java 8, and Java 8 is a huge improvement over Java 7 for that, with Lambdas, Stream API, etc. But really, when you begin to build a functional application, Kotlin provides you a better language for that. So, what looks like our former user controller? What looks like the annotation-based reactive version? You can see that that's barely the same syntax. We reuse the same programming model, but instead of returning a list, we return flux, and instead of returning raw values, we return mono of something to be able to be reactive. But except that, that's almost the same syntax. But we have seen that with Reactor and Reactive APIs, we are using functional APIs, so why not going a step further and replace the annotation-based programming model by a Lambda-based one? So here we are going to, in this last step, we are going to change Spring WebFlux based on the annotation by default to the functional variant of Spring WebFlux. So it shares the same internal engine, but the API that we are going to use is based on lambdas instead of annotations. So in addition to the annotation programming model, you can use this router function that we are going to describe. We are beginning to use a Java version, and then we will switch to the Kotlin one. So this is a regular annotation-based WebFlux server-sent events endpoint. It returns a flux, and you specify the text event stream media type. If you write that with the functional WebFlux Java API without static imports, you write that router function.root. You specify the predicates that allow to match a route. So here we are using the path predicate and the accept predicate that will match a specific media type. That's interesting, but that's a little bit too long. So in Java, we can use static imports to make the code more readable and shorter. So honestly, that's fine for simple example, but I have built, when you build big application, real-life applications, with the Java API, even if the API we have built, I think, is really okay, the limitation of the Java language make that not very readable because you have a lot of parentheses, you have a lot of noise, and does not scale very well. That's why we have introduced the Kotlin DSL. So Kotlin allows us to provide a DSL that looks, so that's exactly the same building blocks. We have the same request predicates. We just express them with a better syntax. So here we define a router with a /code/feed path predicate and an accept predicate. And it's just a regular function, but that's an infix function. In Kotlin, that means that's just a keyword that allows us to call a function without the parentheses. But end is a regular function. And that allows you to describe the route with a nice syntax. So we are going to see more advanced examples. Here is a configuration class called application routes. I prefer in my web application split the router on one side and the handlers in other side. So we inject the handlers that will contain the code really executed, the body of the handlers that will be executed when receiving a request. And we define routers. So it's up to you to define a single router, multiple ones. One advantage of the functional routing is that you are in charge of deciding of the granularity of your routing. With the annotation-based variant, you had to put the mapping, still an issue. You had to put the mapping just at the same place that the handler. With the functional one, you can basically do what you want in terms of granularity. You can see this simple app router which map gets HTTP method on /users and will call fetch all. Fetch all is just a method which takes a server request as input and will return a mono of server response. And you can also use this kind of syntax with a request param. So now let's see even more complex example. So you can use nested routing. Nested routing allows you to basically define a common set of request predicates that will be applied to every nested route. So here we are saying that in the first block, in the first nested block, every request that match with /blog path prefix and accepted text HTML will be route to the nested block, which is /blog/ and /blog/slug. So you can use any number of nested routes, and that's not only impacting that's not only syntactic sugar that define how the route tree will be evaluated when receiving a request. So by tuning the tree, you are also impacting the performance and the order of evaluation of each route. But you can also do more powerful things because functional routes are also programmatic routes. That means with annotation, you have to statically define your routes, and that's all. With the functional API, you can create routes dynamically. In my former job, I have developed some CMS or e-commerce-like feature when the user basically defines some dynamic elements into the database via back office. And when you develop your application, you don't know at all the routes that will be dynamically created based on some data that the administrator has edited via the back office. So with that kind of functionality, I'm able to create one route per shop, basically, and you can use that with more complex mechanism to create routes dynamically at startup, or even make the route dynamic for each request evaluation. That's up to you. Let's have a look to the handlers. So the handlers look like that. Here I'm injecting the repository. You could inject the service if you have a service layer in a more complex example. And you see that each handler method, each handler member function take a server request as input and will return a mono of response, but since Kotlin type inference is very powerful, you don't have to write explicitly that it is returning mono of server response. It will be automatically inferred by the return type of OK.json.body, etc. And with a simple equals syntax for defining a one-liner function, that's look like quite clean. Other handlers example, you can also, obviously with the functional variant, deal with rendering templates. That's not only for REST web services. You can render in one application I will talk about just after. I render a mustache template, or you can render a team lift template. You can also create some server-sent events endpoint, like in this second example, with quite short syntax. So if you want to have a look to a real Spring WebFlux functional Kotlin application, you can go to github.com/mixitconf/mixit. I'm a conference organizer of this MiXiT conference in France. And for the last 6 months, we have rebuilt the new conference website with this stack. And this is the reference application that you can use as an example to see what a real application, not just a demo, but a real application used in production look like. And we use that for 3 months in production without a single issue. So I will continue to update that. So that's a project with the following software design. So it's using reactive and non-blocking runtime, idiomatic Kotlin code, functional routing DSL, immutable domain model, and that's a balance between functional and object-oriented programming. So feel free to have a look. And it's also using constructor-based and non-intrusive dependency injection. You have seen that with Kotlin, I usually don't do injection via setters. I favor constructor-based injection, not only to please Oliver Girk, but because that's really natural in Kotlin to do that way, and that allows us to have val to use immutable fields. And next step is you can go even further. And what about using WebFlux as a micro framework? What I mean is that you can totally use Spring WebFlux functional with Spring Boot, and that works perfectly well. But you have also the choice to use it alone in order to have very super lightweight runtime. So in practice, you will see in the MiXiT project, I have done a branch which does not use Spring Boot at all and directly use Spring WebFlux standalone. It is using functional bin registration because Spring Framework 5 provide a new injection, a new way to define your bins. I will show an example just after. And in terms of memory consumption and startup time, you see that the annotation-based version with boot is already very fast, 3 seconds to start up for a real project, and only consume 20 megabytes of heap size after a garbage collector. So that's very lightweight. But if you want to really go even further and have a very fast startup time and very low memory consumption, you can use WebFlux standalone. In my application, the application starts with 1.2 seconds and consume only 10 megabytes of memory after a garbage collector. One thing interesting is this functional bin registration API, which is a good fit with an application that already uses functional API for the web parts and for the reactive API. So after XML and Java config it's add configuration with add bins annotations. We are adding with Spring Framework 5 a third way to register your bins using Lambdas. In fact, the Lambda will be used as a way to perform deferred instantiation of the bins. So Lambda supplier will act as a factory bin. And that's not only about expressing that in a different way with syntactic sugar. That's the most efficient way to create your bins. It implies no reflection, no CGLib proxies, and we provide a customized Kotlin extensions. You can see this example to define your application context. So you can see the functional bin registration of a branch of MiXiT application. with a real example of creating. So let me be clear, that's not anymore a Spring Boot application. So you have to create, like in the old days, your application context. Maybe later we will provide some facilities to maybe do more high-level stuff. But for now, you are responsible to build your application context with that, and that allows you to write, to have a very, very fast project. It should be possible to use the functional bin registration API with Spring Boot. We are working on that, even if internally Spring Boot is using the Java config thing. And the very last topic is front-end development, because like we have seen, I like using Kotlin everywhere. And I'm not only a back-end developer, I'm also a front-end developer, and I really care about the front-end development. Not because Kotlin is great and that's all. The goal is to limit the number of technologies that you have to learn. Modern JavaScript development means that you have a whole ecosystem to integrate with Node.js, with NPM, things like that. So I think there is some improvement that could be done there. Kotlin 1.1 don't target mainly the JVM and Android, but also compile to JavaScript. So it could be used to replace JavaScript or TypeScript for your front-end code. It has very good JavaScript interop, so you can call JavaScript code from Kotlin front-end code. It could be used to have a single language for your web app and share code between backend and frontend, for example. But currently, it generates big JavaScript files because basically almost all the Kotlin standard library is compiled to JavaScript, and by big I mean maybe 300 kilobytes for a simple hello world. So I'm not very happy with that. Kotlin 1. So it's usable, but it will produce quite large JavaScript files. Kotlin 1.2 will introduce tree checking, which will analyze dynamically what part of the code is used and what part is not, and it will remove all the unused code. So for production, I think Kotlin 1.2 will be ready to be used on the front end. Another forward-looking topic is WebAssembly. So basically, compiling a non-JS-based language to JavaScript is a hack. Everybody does that nowadays, but that's a hack. And there is a new compilation target that is coming to the web. So I'm not sure you have heard about that, but the 4 major browsers support WebAssembly, or are in the process of supporting WebAssembly. That's basically the web bytecode. So that's a binary format that is understood by the browser and that can be used to execute faster, smaller front-end application. You can read the introduction to WebAssembly written by Lynn Clark from Mozilla. That's a very short, concise, and a cleverly explained introduction to WebAssembly. So let me be clear, Kotlin currently does not support WebAssembly, but I push very hard to make sure that happens, and I really hope that in the medium-term future, Kotlin will be able to compile to WebAssembly. WebAssembly is currently mostly C++ oriented, so it currently works in your browser without a flag if you have Chrome or if you have Firefox. It's mainly C++ oriented, that means it's used mainly for games, for example. But it's changing. DOM and Web APIs are going to be available from WebAssembly. It's going to support garbage collector, exception handling. That means it will be shortly a viable a compilation target for languages like Kotlin, Java, Swift, etc. So I think Kotlin could support that because there is a Kotlin native initiative. So a few months ago, JetBrains announced Kotlin native, which leverage LLVM toolchain to compile Kotlin to native code. So I don't say it will take your Kotlin JVM-based application and compile that to native. That's a totally different standard library. You can't do that. But the idea would be to leverage Kotlin native to compile to WebAssembly through LLVM toolchain. And if your browser has not WebAssembly support, it will gracefully use ASMJS to execute it, because WebAssembly is basically the next step after ASMJS. So don't believe me, try Kotlin. I mean, almost all the developers I know that has really tried it like it. So I think that's a nice language. You can go to this kotlin.link website, which provide all the links to Kotlin. Especially the Kotlin Slack is a very friendly place where you can directly discuss with the community. There is a Spring channel there. There is very helpful people, and in addition to the language, what I like in Kotlin is the community is very highly skilled, friendly, and very interesting. I will publish, it's not available yet, but I will directly publish the slide on my Twitter account, and feel free to have a look. Thank you. Thanks.